Hi, this is Mrs. Sigmund. We're going to look at section 2.4, solving equations with variables on both sides. Again, we're still in unit 1. The date might be a little different for you, but hopefully you are doing this in the week that starts with September 7th. Okay, we're still solving equations the same way we have. We already looked at multi-step equations, but in all of those scenarios so far, the variable has only been on one side of our equation, whether that's the left or the right. Today we're going to look at some where the variable shows up on both sides. And our first goal is going to be moving those variables all over to one side and then simplifying the rest. Okay, so here you can see a negative 3x on the left and a positive 1x on the right. It doesn't matter where you move your variables. My recommendation would be to keep things positive. So if I kind of think ahead here, if I subtract my 1x to the left side, it's going to leave me with a negative 4x. But if I add 3x to both sides, goes away over here, and I'm left with negative 7. And I have a positive 4x, and that might be a little easier for us to work with later on in the equation. There we go. Okay. So now this should look like our multi-step process. We have x's now only on the right side. So we'll move the 13. We'll subtract 13. Be careful with your negatives. I now have a negative 20 equals 4x. 4x again is multiplication, so we will divide. And that leaves me with a negative 5 for x. If you move the x at the beginning, you should get the same answer, except that you will end up with a negative 4 in this step, and then you'll have to divide by a negative, and sometimes that gets a little tricky. So I think keeping them positive is better, but it's not the only option that you have. Okay. Again, I want to think ahead and try to figure out which of those variables to move so that they stay positive. I'm going to move the 3x. It's positive right now, so we will subtract that. 5x minus 3x leaves us with 2x. Keep the minus 12, and then keep the positive 2 that's on the right. Then we'll add 12 to both sides. And these go away, so we have 2x equals 14. 2x is showing us multiplication, so we can divide both of those by 2 to get x equals 7. Here I have an extra step. I see some parentheses, and so our brain should be telling us we need to distribute. We're going to take that negative 2. That's going to go to both pieces in parentheses. So before I do anything with the variables, we're going to take care of the parentheses. This gives me negative 2x and a positive 6 because we had negative 2 times negative 3. Now I want to make sure my variables stay positive. I'm going to move the 2x. It's negative, so we will add 2x to both sides. That leaves us with a 3x minus 6 on the left and a positive 6 on the right. I'm going to add 6 to both sides. Those go away. 3x equals 12. And then we'll divide by 3 to get our answer of x equals 4. Okay, we have some fractions here. So we have a few options. We could change everything to have a common denominator. 2 and 3 would have a common denominator of 6. So I could make them all some number over 6 for each of those 3 terms. Or a way to eliminate this, again, fractions kind of show us division. We can multiply the whole equation by some number that would simplify and eliminate the 2 and the 3. So we want to think, what do 2 and 3 both go into? Well, they both go into a 6. And I'm going to distribute a 6 to all 3 terms. I'm going to show you what that looks like. So we have 6 times the 1/2 y equals 6 times 1/3 y plus 6 times 2. Don't forget about the 2, even though it's not a fraction right now. 6 times 1/2 y gives me 3y. 6 times 1/3, I'll just show you real quick how we're doing this. This is like a 6 over 1. And so I would have 6 times 1 over 1 times 3, which gives me 6 over 3. And that just reduces down to a 2. It's also the same thing as 6 divided by 3. So we're going to get 2y here. And then my 6 times 2 gives me 12. Because that 3y is all by itself, I'm going to move the 2y over there. I get a little lucky because that already keeps things positive. That gives me just a 1y, or y equals 12. And then we're done because we don't have to divide anything in this one. Okay, I want to talk about some special cases. If you start to move things around and your variable cancels out or kind of disappears, then we either have what's called an identity or a no solution scenario. We would get an identity if the numbers left over are equal on each side, like 0 equals 0, or we would get no solution if it was a false statement, like 0 equals 15. So we'll look at some of those. Okay, again, I'm going to distribute the 2 to start. We get 6w minus 14 equals 7w plus 9 minus w. I have 2 w's on that right side, so I'm going to simplify that. And now I want to move my w's all on one side. So maybe I subtract this one. I have to do it on both sides, but they're going to go away. And I'm left with negative 14 equals 9. There's no variable. That's not true. So our answer is no solution. Negative 14 equals 9 is our work, but your answer is no solution. Okay, here again, I'm going to do some distributing. I'm going to go ahead and do both of those in this first step. Be careful with your positives and negatives. So I get a positive 15 here. And then I'm going to combine like terms. So we have 2 j's on the left and then 2 what we call constants because they don't have variables on the right. So we get negative 9j plus 15. And over here, I get a 15 minus 9j. Then when I go to move variables to be on the same side, maybe I move this guy. You'll notice things go away again. I'm left with 15 equals 15. That's true. So again, that's not my answer, My answer is identity. Okay, that finishes out variables on both sides. So you can do the assignment that's on Reveal 2.4, or again, there's a PDF available